Now let's do question 5, which is for 16 marks. Let's just read out the question for our reference. So, the student wanted to study the relationship between fish growth and the mass of fish food. After feeding each fish with a different mass of food every day, they measured the length of each fish after 1 month. They used several fish tanks, some fish, and a large fish food container. So here we have the image. I think this is their setup. So we have a ruler over here. So I think this is going to be one of our equipment. So we'll just keep this in mind. Next, we have fishes, we have an aquarium, we have all of that. Now we have our design and investigation question. So let's just read it out for a reference. Design an investigation to study the effect of different masses of fish food on length of on the fish length after 1 month. In your answer, you must include the independent variable, the dependent variable, and two control variables, a hypothesis, a list of additional equipment required, how the variables will be manipulated to collect sufficient data, and a description of our method. So now we're just going to list everything we need. Okay, first let's get started with the variables. So first we have our independent variable. Let me just get started with this. Let's write independent variable. So our independent variable, which is our IV, is going to be the mass of fish food given to the fish every single day. Mass of fish food given to the fish. We'll just write this as our independent variable, and we're going to mention the value as well. Okay, we'll just put it in grams. And next, let us have the dependent variable. The dependent variable is going to be the variable that will be affected by the by our independent variable. So the mass of fish food can affect the final length of the fish. So we're just going to write that as our dependent variable, which is going to be the final length of the fish in centimeter. That's our independent variable. Let's just write two control variables. Control variable, we'll just go ahead with the water temperature. Control variable 1 is going to be the variable that we're going to control, alright, because controlling our variables is really important, because when we're performing an experiment, the thing is that there are certain external factors that can actually affect our findings. So to ensure that our findings are reliable, they're accurate, and there are no anomalies present, we have to have at least two control variables. So one of this is going to be our water temperature, because water temperature can actually affect the growth of the fish. As we've seen in the previous questions, we saw a question related to the water that they were in, and I don't really remember, but there was this question related to the water temperature. So we're gonna keep water temperature as a control variable because it can actually affect the fishes. Oh yeah, there was a question related to the respiration rate. So yep, the water temperature can actually affect the respiration rate of the fishes, and it can and that can hinder the growth. So we're gonna put our control variable as a water temperature. Next, let's do control variable 2. The control variable 2 is going to be our species of fish. The fish species, they should be the same, because different species of food, they might react differently to the nutrition, like I mean they might react differently to the food given to them. And in this paper, as we've seen again in the first, I think it was, I don't remember the question number, but there was a question that explicitly asked us how, there was this valid or invalid question. I remember they just asked us about how the fish, they just tested to see whether giving the same mass of food to different species would get similar results. They will yield similar results, but no, it was not like that. So that's why the species of fish, they're going to be our control variable too, because controlling which species of fish we use can actually get better results for us, because every type of fish, it has certain nutritional requirements, and it like it has like they grow in different ways. Everything is not similar, everything is unique in its own way. So we're going to take this species of fish as a control variable too. Next, we have our hypothesis. So let me just give you a heads up before we write the hypothesis. An important thing you need to remember before writing your hypothesis is that you're always supposed to follow the if then because format. So this will help you formulate a clear hypothesis, and you actually know what to write instead of just being confused most of the time. So let's just formulate our hypothesis now. We'll use this as an example and then we'll break our hypothesis down to understand why this format is required. So let's write, if the mass of the fish food given to the fish each day is increased, then the final length of the fish after 1 month will increase because greater it can be because a greater intake of nutrients and energy will allow for the fish to produce more biomass for its growth. This is going to be our hypothesis. Now let's just break it down and understand why this format is required, and let's understand our own hypothesis as well. So first things first, we have written the if part, which is where we write if the mass of the fish food given to the fish each day is increased. So we're saying what would happen if we increase the mass of the fish food given to the fish each day. So our then part basically is the what would happen. So then the final length of the fish after 1 month will increase. So we're just talking about the effect of the if part on the then part. So that is the if and then part summarized. And then the biggest part is needed because you're supposed to explain why it happens, why the final length of the fish will increase. So the because is going to be because a greater intake of nutrients and energy will allow for the fish to produce more biomass for its growth. So this is the biggest part where we explain why and how the if and then part gets affected, like how the if affects the then. Because if we increase the mass of the fish food given to the fish each day, then obviously it will get more nutrients, right? It will have a greater intake of nutrients and energy, which allows it to produce more biomass for the growth, which ultimately results in its final length increasing. So that is the biggest part, and that is why you have to follow this format. Remember again, if then because format. Then we have our additional equipment. Let's just write additional equipment down. So for additional equipment, one thing you need to be considered about is that if they give the equipment already in the in the experiment, you don't need to write it down. They won't give you marks for it. So for example, over here we've seen that they've given us a fish tank and a fish tank, a ruler, certain fishes and all of that, but I don't necessarily think that we need to write about the ruler because they won't give you extra marks for that. They're asking for additional equipment and they're not asking for the existing equipment. So additional equipment is going to be, first things first, is going to be a balance to measure, let's just write it in brackets, to measure the mass of the fish food. That's what our balance is for. And then a thermometer, which is to monitor the water temperature. We need all of this. We need the thermometer we need it for our control variable 1 to manipulate it. Then identical fish tanks are required, because if you keep the tank size constant, then the volume of water will not affect your findings, because the volume of water is also another control variable that you can write, and that will not necessarily affect your that will affect your findings. So if we have identical fish tanks, then obviously the volume of water is going to remain the same, and then there will be less anomalies in your results and you will have more precise results. Then identical fish tanks, and then let's write let's just write not a water heater, but we can just go for a temperature control aquarium system. Temperature control aquarium system, and this is to maintain a constant temperature in the water. To maintain a constant temperature. So this ensures that the temperature in the fish tanks, they are the same, and that the water temperature is not affected. It stays the same. We need that, and then after this we're gonna write about the variable manipulation. Let's just write a variable manipulation over here, and I think we know what to do over here, because we already understood the independent variable, dependent variable, and then in our equipment we learned how, we just understood how we can manipulate the control variables using this. And then over here in the variable manipulation, there's a simple format that you need to follow. That is going to be, first you have to write the variable which you're going to manipulate. And so let's just write independent variable, just write how you're going to manipulate it. So for the independent variable, which is the mass of food, we're going to manipulate it by measuring different masses of food and giving it to the fishes, and then we measure that using a balance. So we're going to manipulate it using a balance, and then we feed the corresponding amount to the fish each day. So let's just write that down. The mass of fish food will be manipulated by measuring 1 grams, 2 grams, 3 grams, 4 grams and 5 grams of fish food using a balance and feeding the corresponding amount to the fish each day. So that is going to be our independent variable, and how we're going to manipulate the independent variable. Then for the dependent variable, which is going to be the length of the fish, so I think we're gonna look at the fish length after a month, right? So we're gonna write after 1 month, the final length of each fish will be measured in centimeter, which will be like using the ruler that was provided, and the data will also be recorded. So we see in the image over here, they provided us with the ruler. So we're just gonna measure the final length of the fish using the ruler, and then the data will be recorded. So that's how we're going to manipulate the dependent variable. Let's just write it out. After 1 month, the final length of each fish will be measured in centimeters using the ruler provided. The findings will also be recorded in a table. So that is how we're going to manipulate our dependent variable. So that's it for dependent variable. Next, let's talk about our control variables. I think we've already gone through this. So let me just control variable 1. So we're gonna manipulate a control variable 1, which is a water temperature, using a thermometer and the temperature control aquarium system. So that's how we're gonna manipulate control variable 1. Let's just write it down. The water temperature will be manipulated by using a thermometer to monitor the water temperature, and by using a temperature control aquarium system, not using, by implementing, we can say, by implementing a temperature ecosystem to keep the water temperature constant throughout the investigation. So we're gonna keep the temperature at 25 degrees, the water temperature 25 degrees Celsius. You're gonna get the option to put 25 degrees Celsius in the paper, but I can't really do it because I'm not in the software, not in the official IB software. So that's it for a control variable 1. That's how we're gonna manipulate it. And then for a control variable 2, let's just write it's for the species of fish. So we're just gonna write the species of fish will be manipulated by using the fish of the same species throughout all the tanks and the investigation. So we're just basically going to use this fishes of the same species throughout the investigation, and that's how we're going to manipulate a control variable too. We're going to keep the fish species constant and not like just take any random species. So that's it for this. And then for our method, which is the last one, the method, we're just going to, the method should be replicable by whoever reads it. For example, let's say that I'm a student who wants to do this experiment. When I look at your method, I should be able to understand what to do. Like the steps should be concise, they should be easy to understand, and I should be able to replicate the experiment on myself. So that's how we're going to think while writing our method down. So the first step is going to be, we're going to set up 5 identical fish tanks which each contain 20 liters of water. So that's going to be our first point. Set up 5 identical fish tanks each containing 20 liters of water. So we'll just specify how much water we need, so if another student wants to replicate an experiment, they know what to do and how much water they need to take. And next, the second step is going to be place fish of the same species and similar initial lengths into each fish tank. So we're gonna place fish of the same species and similar initial lengths into each of these fish tanks. Next, third step is going to be measure 1 gram, 2 gram, 3 gram, 4 gram and 5 gram of fish food using a balance method. So this is important because we need to measure the fish food before giving it to the fish, because if we don't measure it properly, then we might end up giving 2 grams to the fish in the 1 gram tank and 5 grams to the fish in the 3 gram tank. So it can basically cause errors in our values again. So that's why we're going to measure them beforehand, and we're going to stay ready for whatever we're going to do next. The fourth step is going to be feed 1 gram of food per day. Let me just capitalize F. My bad. Feed 1 gram of food per day. The second tank 2 grams per day. To the first tank. To the first tank 3 grams of food per day to the third tank. 4 grams of food per day to the fourth tank, and 5 grams of food per day to the fifth tank. For a month. So we're gonna just keep giving 1 gram of food for the 1 gram tank. Similarly for all the other tanks, depending on how many grams of food how many grams of food the tank has to receive. And then we're gonna keep on doing this for a month. So every single day these things, they have to get the mass of fish food that the tank requires. Next, the fifth step is going to be monitor the water temperature regularly using a thermometer and maintain it at 25 degrees Celsius in all the tanks. So we're basically going to monitor the water temperature regularly by using a thermometer, and then we're going to maintain it at 25 degrees Celsius in all the tanks using our temperature controlled aquarium system. It's quite a huge name actually for something like that, but okay, this will do. The next sixth step is going to be, after 1 month, measure the final length of each fish in centimeters using the ruler provided. So we're just going to measure the final length of each fish after 1 month is over to check the final length of each of the fish. And next, seventh step is going to be record the results in a table. We're just going to record the final length of each fish in the table. Next, we're going to repeat this 3 times. We're going to repeat this entire investigation 3 times, so for 3 months, because it's really important that you mention repetitive trials, because if you don't, then your data won't be reliable. Because the first time when you the first time when you conduct an experiment, if you conduct it again the second time, the results will be different. Like, you will have slight differences, so you don't really know what to do, because the data you have, it's not completely accurate. So if you take multiple trials, then obviously you'll have more accurate and precise data, and you'll be actually closer to the desired result, compared to if you only take, if you only perform the experiment one time. So that is why it's important to conduct multiple trials. So our eighth point is going to be that repeat the investigation 3 times for each mass of food. Next, after you repeat the investigation 3 times, you record the data in the table again, and then you just calculate the average final fish length for each mass of fish food. Then you basically we just the next step is going to be compare the averages to determine the effect of fish food mass on fish length by plotting a graph. So that is it. We have 10 proper steps mentioned, and then that's going to be our method. I think if a person looks at this, I can replicate it quite easily, so that's sorted. Then we've got everything formatted properly. We have our variables, we have our hypothesis, we have our additional equipment, we have our variable manipulation also listed. We're just writing about how we're going to manipulate the variables, how we're using the equipment to manipulate our variables. And then for the method, we've written 10 easy steps that anyone, like any student, if they're interested, they can replicate. So I think we're quite successful with our answer, and you can follow this format because it will really help you in your assessment. It will save you a lot of time, as you're not over explaining stuff, you're staying concise, and then the examiner or whoever's checking your paper, they'll be able to understand what you're writing. So whatever paper you have, you can follow this format, and that is it for this question.